the third lesson, lesson number 3. Actually, not lesson number 3, the part 3 of the lesson inequalities is solving general inequalities, solving the quadratic inequalities, cubic, even higher order general ones, quotient, inequality. Let's just recall from the last 2 videos a few things, and then I proceed to the lesson of today. Let's say the question is solve 2x plus 1 plus 3 is equal to 5. Of course, this is not an inequality, this is equality. So we have mod of 2x plus 1 is equal to transpose 2. Therefore, modulus of 2x plus 1. Therefore, 2x plus 1 must be equal to plus or minus 2. We said that if modulus of m is equal to 10, then m could be plus 10 or minus 10. Therefore, 2x plus 1 is equal to 2, or we have 2x plus 1 is equal to negative 2. Therefore, 2x is equal to 1. Therefore, x is equal to half. Or we have 2x is equal to negative 3. Therefore, x is equal to negative 3 by 2. So equalities always give us solutions, not regions. So the solution here is barely x equal to half and x equal to minus 3 by 2. Supposing you look at the inequality, let's say absolute value of let's say 2x minus 1 plus 8 is equal to 7. Then we have absolute value of 2x minus 1 is equal to minus 1. Therefore, no solution, because absolute value of any number is always more than or equal to 0 for all m belongs to real numbers. And there's no solution for absolute value of something equal to negative 1. A small recall on the last class's work is if you have 5 minus 4 times, let's say, absolute value of 3x minus 1 is less than 1. So we said that we could transpose this. So you have negative 4 times absolute value of 3x minus 1 is less than 1 minus 5. Therefore, negative 4 times absolute value of 3x minus 1 is less than negative 4. We divide by negative 4, the inequality will switch. So you have 3x minus 1 is greater than 1. Therefore, absolute value of 3x minus 1 is greater than 1, which implies that if modulus of m is more than 10, we said that then m must either go to the right of 10 or m can go to the left of minus 10. Similarly, this is more than 1. This implies that 3x minus 1 is less than negative 1, or we have 3x minus 1 is more than 1. Therefore, 3x is less than 0, transposing 1 to the other side, plus 1 and plus 1, 0. Therefore, we find that x is less than 0 by 3. I'm dividing by positive. Therefore, you have x is less than 0. And here 3x is more than 2, transposing by way of addition. Therefore, x is more than 2 upon 3. Therefore, we had the number line here. This was 0. This was 2 upon 3 here. It was either less than 0 or it was more than 2 upon 3 here. Therefore, we said that x belongs to negative infinity to 0 open union. We had 2 by 3 to infinity. We learned all this in the last few classes. One more thing we'll pick up just to make sure that we have followed up with the last two videos, followed up with the concepts of the last two videos. The fourth one there is, let's say you have 1 less than or equal to absolute value of x minus 2 is less than or equal to 3 for that matter. This becomes a system because you have absolute value more than 1, and you can also say this absolute value is less than 3. So now I have to treat this as a system of inequalities, and I treat them as two different inequalities. So I'll say, therefore, I must have absolute value of x minus 2 is more than or equal to 1, comma, we have absolute value of x minus 2 is less than or equal to 3. So this was the green one here, because it's more than or equal to 1. And this was the other one. I have to make sure that I obey both the inequalities there. It's like almost like and compulsion. Now, dealing with the first part here, you'll find that now you find that absolute value of x minus 2 is more than or equal to 1 implies either x minus 2 is more than or equal to 1, or we have x minus 2 less than or equal to negative 1. Therefore, x is more than or equal to 3, or we have x is less than or equal to 1. Therefore, and then going with this one, the second one, you find that absolute value of x minus 2 is less than or equal to 3 implies that x minus 2 is a sandwich between 3 and negative 3. So if you add 2 throughout, so negative 2 plus negative 3 plus 2 is less than or equal to x, less than or equal to, you have 3 plus 2 here. Therefore, x is more than or equal to negative 1 and less than or equal to 5. So there are two things to obey. I have to obey this fellow, and I have to obey this fellow here. So looking at both the conditions, what should I choose? If I go to the number line, it'll be very easy to understand. Supposing this is, let's say, negative 1, this is 1 here, this is 3 here, and let's say this is 5 or something here. Now, going with the first one there, you'll find that the values of x must be less than or equal to 1, less than or equal to 1, and more than or equal to 3. Either less than or equal to 1 or more than or equal to 3. You go anywhere in this zone, that's what the first condition says. Second condition says that you strictly be inside -1 and 5. You be here between -1 and 5. So if you see now, if you have to obey the first inequality and the second one, both of them, then you have no choice but to select the common ground. That is here, this region, and this region here, where the two colors overlapped. Therefore, you find that the solution of this system is given by x belongs to -1. They're all closed one, I guess. It's all closed. So it's -1 here, -1, comma 1, or you choose your values from 3 to 5. So this is the place where you'll find your solutions. This is where the solutions exist. So if you're looking for satisfying this inequality, you can plug any value. And this one, you'll find that this inequality goes good with any values that is selected between 3 and 5 and -1 to 1 here. That's how we solve that inequality. Now going in for quadratic inequalities. Quadratic inequalities. There are beautiful ways of solving quadratic inequalities or any other inequalities by using by looking at the graph of it. That's in the video 4 I'll explain. But here this is purely algebraic treatment. So let's say you have the inequality x squared minus 5x plus 6 is more than 0, let's say. What are the values of x for which this expression is more than 0? You cannot randomly put any value. Let's say, supposing I put x is equal to 1 here, you'll find that 1 squared minus 5 into 1 plus 6 here. This is 1 plus 6 is 7, 7 minus 5 equal to 2. Maybe this is more than 0. Supposing I put the value, let's say 10 here, for example, you'll find that 10 squared minus 5 into 10 plus 6 may be more than 0 or something, but not. I cannot, conclude a certain value, or cannot conclude in general what is the values of x that could be satisfied by this inequality here, unless I really know where it satisfies. So what we do here is that we go for the splitting of the quadratic polynomial by splitting the middle term. So product is equal to 6 here, as you know. Product is equal to 6, and sum is equal to -5. So the numbers are -2 and -2 and -3 and -2 here. So we have x squared minus 3x minus 2x plus 6 is more than 0. If we have x times x minus 3 minus 2 times x minus 3 is more than 0. This implies that x minus 3 times x minus 2 is more than 0. We firstly factorize. No guarantee can be given that every quadratic expression can be factorized. So that's why we have some sophisticated method later on to solve the inequalities. But then in the case where you can factorize like this, or factors are available, then here's the method. Now you have a into b. Supposing, let's say you have a into b equal to 0, you say that this implies that either a equal to 0 or b is equal to 0, and thereby you get the solutions for these equations. But if you have a into b is more than 0, in other words, if a into b is positive, implies that either you have that positive times positive is positive, or negative times negative is positive. So this would actually give you, there are two cases here. It'll give you case 1 here, either or. Either you have x minus 2 is more than 0, or x minus 3 is more than 0, and x minus 2 is more than 0, which implies that x is more than 3 and x is more than 2. Lastly, I told you that if x is, this is 2, this is 3, if x has to be to the right of 3 and also to the right of 2, then the safest x that you could choose is that this implies that x must be to the right of 3, because whenever it's to the right of 3, it's definitely to the right of 2. Yeah, and here you have x minus 2. As I said, both are positive, more than 0 and more than 0, because positive times positive is positive, or both could be negative, because negative times negative is also positive. So you have here x minus 3 is less than 0, and x minus 2 is less than 0, which implies that x is less than 3 and x is less than 2. And if x is to the left of 2 and x is to the left of 3, if you have to satisfy both the conditions, then you can safely choose that this implies that x is to the left of 2. Because if x is to the left of 2, then definitely x is to the left of 3 also. Therefore, I must have, therefore the solution is either x is less than 2 or you have x is more than 3. Therefore, you find that x belongs to negative infinity to 2, or belongs to 3 to infinity here, because x is either to the, that's what this one says, is that x is to the left of 2 here, left of 2, or x is to the right of 3 here, right of 3. So the solutions lie here and here. So these are the places you get solutions. So if you plug the values, if you had to plug the value between 2 and 3, supposing you plug the value, let's say 2.5 or something here into this equation, you will find that the equation is, the inequality is not satisfied. Supposing you put, let's say, x is 2.5, which is not in the zone, you'll find that 2.5 the whole square minus 5 times 2.5 plus 6 would give you here, this is 6.25 minus 2.5 times 2 is equal to 12.5 here, plus 6. You'll find that 6.25 plus 6 will give you 12.25 minus 12.5. Obviously, 12.25 is less, so this is a negative value. So this is not more than 0. So the values between 2 and 3 are not satisfied. So the values that are satisfied are all values between negative infinity to 2 and 3 to or 3 to infinity. This is where you will find the solutions of this inequality here. As I said, there are beautiful ways of solving this inequalities using the graphing technology, but that's in the next video. So this is not my favorite method. Of course, algebraic method I'm talking about, not my favorite method. Look at the inequality of this kind. Supposing you have, let's say, x minus 1 times x minus 2 times x minus 2. Supposing I'm solving this inequality here more than 0, I would almost go crazy here, because the thing is that you have to, supposing you say a into b is more than 0, implied either a more than 0 and b more than 0, or it implied that a less than 0 and b less than 0. Supposing, let's say, you have a into b is less than 0, then also have two conditions here, either a more than 0 and b less than 0, positive or negative is negative, or I have that here a is less than 0 and b is more than 0, positive and negative. So if I digest these conditions, I will get my inequality. When it comes to a into b into c is more than 0, things may not be easy. There are lots of cases here which will actually lead to the positivity. You can have a first factor positive times positive will give you positive. But that's not the only time to use a positive. You may have a positive as the first one, negative and negative, that also gives you positive. You may have a negative times positive and negative, that'll give you more than 0. If you have negative times positive, will give you more than 0. So lots of cases, actually, digesting them is not really possible or easy. It is kind of very, very hard. So what do we do in such case? For this reason, that when you have an inequality like this, it is very hard to solve like this. For this reason, I'll give you another way of looking at this one. We normally don't go for solving the problem this way because it's a little longer. We have a very quick way of handling a problem like this. And then I'll also discuss this problem for you. So let's say, again, let's say we have x squared minus 5x plus 6 is more than the same old problem. So you find that x minus 2 times x minus 3 is more than 0. So what we do here is that we play a different trick. We go for values where this became 0, and the values are 2 and 3. 2 and 3 here. Now these 2 and 3 on the number line divide the number line into 3 zones. So this is 2, this is 3. So this divides the number line into 3 zones. The zone number 1, the zone number 2. Inequality is always zones. They are set of values. So zone number 3 here, 3 zones. So I'll investigate what happens to the inequality in these zones. Supposing I take a value in this zone here. Let's say I take a value, any random value I take. Let's say I take a value 0. So 0 minus 2, I put it in this one, this expression. I put in this expression. So 0 minus 2 is negative, and 0 minus 3 is negative. Hey, negative upon negative is positive, and this is what I want, is more than 0. So this is where I find solutions. Supposing I take the value between 2 and 3, let's say 2.5 I take, I'll find that 2.5 here, if I substitute here, 2.5 minus 2 is positive, 2.5 minus 3 is negative. So the product of positive and negative is negative. So this is where I don't want, because I'm asking for something more than 0, and this is less than 0. Negative is less than 0, so I don't find solutions here. If I go beyond 3, let's say I take 100. So 100 minus 2 is positive. 100 minus 3 is positive here. Positive into positive will give me positive here. So this is where I look for solutions. That's why quickly I came up with the solutions zones where solutions exist. If I'll say x either belongs to negative infinity to 2, or x belongs to 3 to infinity. Yeah, so that makes it really, really quick. I didn't have to go for the case 1, case 2, and digest them like this. Or in this case, I need not go to the case 1 and case 2. So, and this way you can very quickly solve even the inequalities of higher degree. If you could factorize them into linear factors, you could, supposing, let's say I have to solve the inequality. Let's say you have to solve the inequality, let's say x minus 1 times x minus 2 times, let's say x minus 3 is less than or equal to 0, the change. So as I told you, considering the cases that a into b into c is less than or equal to 0 is very hard, because you can have a positive, positive, and negative leading to a negative here. You can have a negative, positive, and positive leading to a negative. So there are lots of combinations of plus and minus signs. So it becomes very hard to digest them. So what I would do is that I'll go quickly for the solutions of these ones here. X is equal to 1, x is equal to 2, and x equal to 3, equating them to 0. So now I divide the number line into zones. We have 1, 2, and 3 here, because the inequalities give rise to the set of values, so that I'll always be in that particular interval. So now what I would do is that I'll substitute a value, the 3 zones here, the zone number 1 here, and then the zone number 2, and 4 zones. Zone number 3 here, zone number 3, and let's see, have the zone number 4 here. So I'll consider a value less than 1. Let's say I take a value 0, for example. So then I substitute in this one. 0 minus 1 is negative. 0 minus 2 is negative. 0 minus 3 is negative. Hey, negative times negative is equal to negative here, and I'm looking for less than or equal to 0. So here lie my solutions. So I found that all the values that are less than 1 obey this inequality. Supposing I took between 1 and 2, let's say I took 1.5. 1.5 minus 1 is positive. 1.5 minus 2 is negative. 1.5 minus 3 is negative. So that will give you the answer positive here. So you find that I'm not looking for positive. I'm looking for less than or equal to 0. I'm looking for negative or 0. So this is positive. That's why these are not the places where I find my solutions. If I went between 2 and 3, let's say I took a value 2.5 between 2 and 3, so you'll find that 2.5 here, 2.5 minus 1 is positive. 2.5 minus 2 is positive. 2.5 minus 3 is negative here. So plus into minus will give you a negative answer. So, and this is where I want to find solutions. So this is my solution set. So if I went for the values more than 3, let's say I took 100. So 100 minus 2 is positive. 100 minus 1 is positive. 100 minus 2 is positive. 100 minus 2 is positive here. So it will give you a positive. but then I'm looking for less than or equal to 0. So here I don't find solutions. So the only place that I find my solutions are x belongs to negative infinity to 1. It's less than or equal to 0. So you can include it by close bracket, less than or equal to. So that leads to equal to. Or you have here, you have 2 to 3. So this is 2 to 3 here, closed 2 to 3. So these are my solutions from here till here as my solutions. This region is my solution, and from here onwards below is my solution. So this is where I find my solutions for the inequality. So that makes it pretty quick to solve any inequality where even if you have a higher degree inequality, if you could just factorize it into linear factors, you can find the zeros, and you could quickly come up with, you can have a small little table drawn of so known as a sign chart, or you can just draw the number line and get your answers like this. So let's say someone is asking you to solve the inequality. Let's see, the inequality, let's say x cubed minus 6 times x squared plus 11 times x minus 6 is, let's say, more than or equal to 0. Yeah, looks very complicated. Now, if I have to search for the values of x which is more than or equal to 0, it's very, very difficult task. So understanding this as the inequality, it's a polynomial inequality. So what I would do is that I take a deep breath and see, oh yeah, maybe I can factorize this into linear factors. As I told you earlier, in the next video, the video of solving inequalities using graphical method, that's a very quick solution. It's just plug it in the graph and then you get the answer at once. But if I have to algebraically find out, what I would do is that I'll first factorize this one. Supposing I call the polynomial as p of f of x is equal to, or p of x equal to x cubed minus 6 times x squared plus 11 times x minus 6 here. Sum of all the coefficients equal to 0. Therefore, x minus 1 is a factor. Or by trial and error method, you'll find that f of 1 becomes equal to 1 minus 6 plus 11 minus 6 is equal to 0. Therefore, by factor theorem, you'll find that x minus 1 is a factor. Now you find the other factor. Either you divide by synthetic division, if you know of. Otherwise, you divide by long division to find the other factor. You have x cubed minus 6 times x squared plus 11 times x minus 6. You divide this one with, let's say, x minus 1. So x divides x cubed, x squared times. You have x squared times x is equal to x cubed. X squared into minus equal to minus x squared here. Subtract minus and plus. You have 5 times x squared plus 11 times x minus 6. X goes in 5x squared plus 5x times here. So you have 5 times x squared minus 5 times x there. Therefore, minus and plus, you have 16 times, I'm sorry, 1 times x minus 5x here plus 5x squared minus 5x. Some trouble. Now we are x goes in x cubed, x squared times x squared into x squared equal to x cubed. X and minus 1 is equal to minus x squared here. So plus, oh yes, minus 5x squared is equal to minus 5x squared. So you have minus 5x here. So you have minus 5x squared and you have plus 5x here. So then you subtract this one, you'll find that becomes plus and becomes minus. Subtract becomes cancels. 6 times x minus 6 here, so it becomes equal to plus 6. You have 6 times x minus 6 here. Subtract plus and use it. Therefore, you find that f of x becomes equal to x minus 1 into x squared minus 5x plus 6. I purposely chose these values. This one we factorized earlier. It comes x minus 1 into x minus 2 into x minus 3 here. So talking about f of x is more than 0, more than or equal to 0. You're talking about x minus 1 into x minus 2 into x minus 3 is more than or equal to 0. Then the same story. So you have x is equal to 1 here, you have x is equal to 2, you have x is equal to 3 here, and then you go for the zones 1, 2, and 3 and look for these values here. So when x is less than 1, let's say 0, 0 minus 1 is negative, 0 minus 2 is negative, 0 minus 3 is negative. So the answer is negative. You don't want this. Take between 1 and 2, you find that between 1 and 2, 1.5 minus 1 is positive, 1.5 minus 2 is negative, and 1.5 minus 3 is negative here, so that becomes equal to positive. So we want this, and then between 2 and 3, you'll find that 2.5 minus 1 is positive, 2.5 minus 2 is positive, 2.5 minus 3 is negative here. So the answer is negative. We don't want that because we're looking for positive here. And then more than 3, let's say 100 minus 3 is positive, into positive, into positive. So that's equal to positive. Therefore, we want this one. Therefore, you find that the solutions this will exist between, it's again closed interval because I put more than or equal to. So it is more than or equal to the closed interval. So you have here 1 and 2, or you have 3 to infinity. This is where solutions will lie. That's about that. Let's copy this idea into, let's copy this idea into quotient inequalities. Let's pick up some quotients. Supposing, let's say you have 2x minus 3 upon 7 is more than 10. I told you last time, there's no problem at all if you find that this is positive transpose, the inequality is maintained. If this number is negative, then transpose, no problem, and switch the inequality. Because in any case, this is a number, so you know it's positive or negative, so transposing is no trouble. So the video one clearly explains all those things there. But then what if you have something like this? Let's say you have x minus 1 divided by x minus 3 is, let's say, more than 0. X minus 1 and x minus 3. We copy the same idea. What we do is that we study we find the zeros of the numerator and denominator. And the zeros of the numerator and denominator are x is equal to 1 and x is equal to 3. Of course, when x is equal to 3, the expression is meaningless because anything divided by 0, 3 minus 3 is not defined here. So I'm just taking this for the sake of splitting the number line. So supposing I look for 1 and 3 here, I'm aware of 3 cannot be a solution in any case, I know that. So I look at the zones here. So 1 and 3, strictly more than 0. So look for the zone here, zone number 1, and the zone number 2 here. And then this is the zone number 3. So similarly, you take a value which is less than 1. Let's say they take the value 0. You take the value 0, 0 minus 1 is negative. 0 minus 3 is negative. Negative upon negative is positive here. Hey, I want this one because I want the value to be more than 0. Between 1 and 3, if I take a value 2, for example, 2 minus 1 in the numerator is positive. 2 minus 3 is negative. So the answer is negative here, less than 0. So I don't want this one because what I'm looking for is that it's more than 0, positive. This value must be more than 0, positive. So positive is here, but then And then if you take a value more than 3, then say you take a value 10. 10 minus 1 is positive. Upon 10 minus 3 is positive here. So that'll give you positive. So I want that value. So where you'll find a solution is that if it'll say x belongs to, you have a negative infinity until 1 open interval, union 3 to infinity. I made sure that I dropped the 3. Even otherwise, the strict inequality otherwise also will drop the value at that point. But even if you have more than or equal to 0, I would have dropped the 3 because at 3, the function is not defined, the expression, the quotient is not defined. So this is where you find solutions actually. So if you plug a value less than 1 in this expression, or if you plug a value more than 3 in this equation, the inequality is satisfied. So graphically also, it's very interesting to see how these inequalities can be just solved, in fraction of a minute by just looking at the graph, like how these inequality, the inequalities have solution. But this is how this purely algebraic treatment, algebraically finding out what the solutions are for the given inequality. So let's say here I was fortunate. Everything was compared with 0, so things were easier. What if I have the question like this? Solve the inequality, let's say 5x minus 6, for example, divided by x plus 6 is less than 1. Now the trouble, less than 1 is, that, you cannot say it's positive or negative. So less than 1, there is positive is also there, negative is also, it doesn't make sense to compare with 1. So what is that? We play the same old trick, same old monkey trick, that you compare with 0. So you transpose to the other side. Transposing a number by way of subtraction does not change the inequality. It doesn't disturb the inequality. So I'll smartly bring that 1 to the left side. So you have 5x minus 6 divided by x plus 6 here. Minus 1 is less than 0. Like subtracting 1 and subtracting 1 both the sides. The inequality does not get disturbed. So you achieve a 0. That's the whole big idea. That's what the trick is. Now I know that. Now I can discuss the problem in the same terms as this one, because we already know how to control when it's compared to 0. So what I would do is that I'll just hold a bit of work here. So you have 5x minus 6 minus of x plus 6 here, taking the LCM upon x plus 6 is less than 0. I'm not doing anything that will disturb the inequality. The inequality doesn't even know about it actually. So 5x minus x here is equal to 4 times x, and minus 6 is minus 6, and minus 6 is minus 12 here, divided by x plus 6 is less than 0. So you can also, you find that there is a 4 in common here. You can also divide by 4, and that's not bad. Dividing by 4 is positive. So if I'm dividing both the sides by 4, then x minus 3 upon x plus 6 is less than 0. The inequality is not disturbed when you divide both the sides by 3. Yeah, so I can reduce the burden by just reducing by dividing by 4 here. Dividing by 4, 4 is positive. For that matter, even if I divide it by -4, there is a negative sign, then the only thing is that I'll switch the inequality around, because I know that that comes with a certain sign, that definite sign there. Now the same story again. What I can do is that here I have, I look at the zeros of the numerator and denominator. So x minus 3 is equal to 0 gives you x equal to 3, and x plus 6 is equal to 0 gives you x equal to minus 6. Yeah. Now I'm talking about minus 6. I'm always a little uneasy about it actually, because the denominator is 0, the expression is not defined. But I'm only considering them just for determining the zones. -6 and +3 here. So I have 3 zones. The zone number 1 is like this. The zone number 2 is this one here. And the zone number 3 is this one. So Now I consider the value less than -6. Let's say -100. -100, -3 is negative, 103 is negative. -100, +6 is negative. So that'll give you a positive sign here. I don't want this because what I want is less than 0, negative. I want this one to be less than 0, negative. So something is less than 0 means something is negative. So I'm just looking for something being negative. So I got positive. If I took a value between -6 and 3, I can take a 0 for that matter. But -6 and 3, there's a 0. So 0 minus 3 is negative. 0 plus 6 is positive. Negative upon positive is negative. So this is what I want. And if I take a value within more than 3, let's say 100, 100 minus 3 is positive, 100 plus 6 is positive. So you have a positive here. I'm not looking for these values. So the only value that satisfies this one is therefore x belongs to, you have -6 open and open 3. And this is less than 0. So open makes sense on both the sides. Otherwise, I would have opened at -6 because it's in the denominator, and I would have closed at 3 had it been less than or equal to, but then it's strictly inequality. Therefore, I would just write open both sides. This is the solution where the solution, this is the part where solutions exist. Let's take up some of them, some more of them. Let's say we have the inequality of the kind, say 2x plus 4 divided by x minus 1 is more than or equal to, let's say 5. Again, the same monkey trick that we just bring this 5 to the other side here because I can't compare with 5. I can only compare with 0 because that tells you about positivity and negativity. So then it's easily understandable what is positive and what is negative. So with comparing with 5 is not possible. So the first job is that bring the 5 to the left side. And that's by subtraction. So you have 2x plus 4 divided by x minus 1. -5 is more than or equal to 0. Therefore, you find that 2x plus 4, -5 times x minus 1, taking the LCM, upon x minus 1 is more than or equal to 0. Hey, this is 2x plus 4 minus 5x plus 5 divided by x minus 1 is more than or equal to 0. Therefore, you find -3 times x plus 9 divided by x minus 1 is more than or equal to 0. So -3 times x minus 3 divided by x minus 1 is more than or equal to 0. If you wish to divide by -3, your wish is granted. What you can do is that just be careful when you are fulfilling your wish. So the inequality will switch around. So if you divide by negative on both the sides, that's fine. That's absolutely fine. Doable. So you find that x minus 3 upon you have x minus 1 is less than or equal to 0. The inequality will immediately get disturbed and switches around. So now the same story again. So you have a 1, you have a 3 here, you have 3 zones. Zone number 1, zone number 2, and zone number 3, where you can find your solutions. Zone number 2 and zone number 3. You find solutions. So you find that when x is, if you take a value less than 1, let's say 0, 0 minus 3 is negative, 0 minus 1 is negative, so the answer is positive, is equal to positive. But I'm looking for less than or equal to 0. I'm looking for less than or equal to 0. I'm looking for negative. Looking for negative. If you're looking for less than or equal to 0, you're actually looking for negative or 0. So this is positive, so I wouldn't like it. Between 1 and 3, if I take, let's say you take 2. 2 minus 3 is negative. 2 minus 1 is positive. Negative upon positive is negative here. And I'm looking for negativity, so this is true. If I take value it's more than 3, let's say I take 100, 100 minus 3 is positive. Upon positive, it will give you a positive here. I don't want those values. Therefore, you'll find that my solutions will be from solutions are x belongs to closed A, closed one, Oh no, not close one. One could not have been closed actually because one is in the denominator. So you go for open one here. Avoid the one because one is not a solution in any case actually for here because it goes to infinity. So open one, but you can close the 3 here. You can close the 3 because it's less than or equal to. So 3 is also a part because if you sub the value x equal to 3, I'm sorry, sub the value, let's say x equal to 3 here. So 3 minus 3 is 0, 0 by 2 is less than or equal to 0 for equal to 0. So less than or equal to 0 is true. Therefore, this is the solution for the equation. Just beware of the denominator. Just make sure that you drop it by writing the open sign there. That's the only thing. Talking about let's say you have another inequality. Let's say you have solve x plus 3 divided by, let's say x minus 2 is less than or equal to 2. Again, the same thing. So x plus 3 divided by x minus 2, negative 2 is less than or equal to 0. Therefore, we have x minus 3, x plus 3, I'm sorry, minus 2 times x minus 2 divided by x minus 2 is less than or equal to 0. Therefore, you find that x minus 3, x plus 3 minus 2x plus 4 divided by x minus 2 is less than or equal to 0. Therefore, negative 2x positive 7 divided by x minus 2 is less than or equal to 0. I wouldn't like a negative sign. So if you want a negative out here, this is equal to x minus 7 divided by x. I like the variable in the front for sure, x first, but I don't like the negative expression here. So what I would do is that I divide or I multiply both the side by negative 1. I told you if you have negative a is less than b, then a becomes more than negative b. Or if you have negative a is less than 0, then a is more than 0. So basically, if I multiply both the sides by negative 1 or divide both sides by negative 1, you'll find that it becomes 2x minus 7 divided by x minus 2 is more than or equal to 0. The inequality immediately switches. Therefore, the values are, if you equate the numerator to 0, you'll find that 2x minus 7 is equal to 0. Therefore, that implies that x is equal to 7 by 2. And the denominator is equal to 0. Dangerous. Denominator can never be 0 just for finding out solutions. So you find that x minus 2 is equal to 0, implies that x is equal to 2. So I even feel a little awkward saying that denominator is equal to 0. Denominator is equal to 0, the value of the expression is infinite. So it's just to find out the solutions, we mark those equal to 0 actually. So we have the solutions as you have put them in the ascending order. This is 2 first, and this is 7 by 3.5. 7 by 2 is 3.5 here. So you find that the 3 zones, zone number 1, zone number 2, and zone number 3. So when you take the value which is between less than 2, let's say if you take a 0, 0 minus 7 is negative, 0 minus 2 is negative, so it's equal to positive. Yay, I want that. More than 0. Between 2 and 3.5 is, you can take 3. So 2 times 3 is 6, 6 minus 7 is equal to negative. So 3 minus 2 is positive. So you have positive here that become negative. So I don't want that. I'm looking for positivity. Let's say you take 100. 200 minus 7 is positive. 100 minus 2 is positive. So you have positive here. You'll find that the value is more than 0. So my solutions exist. My solutions are x belongs to negative infinity. It's always open at infinity or negative infinity. Yay, I'm a little scared of the denominator here. But though it is more than or equal to, I don't make mistake of writing that is, I'll write a 2 there, but I'll write open because 2 cannot be included in the solution. So, or we have 7 by 2, the closed. 7 by 2 to infinity here. So this is the places where you find solutions. Let's say you take one more. Let's say we take, let's see you take a system of inequalities now. I'll take a little complicated system. So solve the system. Of inequalities, of course. So you have x by, let's say, 2x plus 1 is more than or equal to a quarter, comma, you have 6 times x divided by 4x minus 1 is less than half. Pretty complicated system. So let's see what agrees with the entire system. What are the values of x which agree with both the inequalities here, respecting the two components of the system, respecting both of them, analyzing carefully and seeing what goes with both of them. So I'll take the first one here now. So you'll find that now I consider the inequality x by 2x plus 1 is more than or equal to a quarter transpose. You have, because I don't know how to compare with the quarter there. So x upon, you have 2x plus 1, negative 1 upon 4 is more than or equal to 0. Therefore, you find that, take the LCM. Here you have 4 times 2x plus 1 here. You have 4 times x negative of 2x plus 1 here is more than or equal to 0. Therefore, 4 times x minus 2 times x negative 1 divided by, you have 4 times 2x plus 1 is more than or equal to 0. Therefore, you have 2x minus 1 divided by 4 times 2x plus 1 is more than or equal to 0. I can't cross multiply anything. If I could cross multiply, I would have done in the beginning itself. So the whole trouble started because x minus 1 upon x minus 2 more than 0 if I couldn't cross multiply here. I told you in the beginning itself, these are variables. So I don't know the nature of them, so I cannot cross multiply. The whole thing began like this. I couldn't simply say x minus 1 is more than 0 times x minus 2. That is not happening because I didn't know what was x minus 2, positive or negative, So I couldn't really transpose that. I should have said in the beginning itself, you cannot transpose when you do not know the sign of that one. So therefore, but now I can always multiply by 4 because 4 is positive. Therefore, you have that 2x minus 1 upon 2x plus 1 here is more than or equal to 0. Multiplying by positive does not disturb the inequality there. Therefore, if we look for the zeros, therefore, when the x becomes equal to numerator 0 is half, the denominator is minus half here. So if I write this one here, negative half and positive half here. So if you take a value which is less than negative half, let's say negative 100 you take. Negative 100, negative 200, negative 1 is negative, and negative 200 plus 1 is negative, so it becomes equal to positive here. And positive I want. And then negative half to positive half, you take a 0. 0 minus 1 is negative. 0 plus 1 is positive. So you have a negative here. I don't want this. And then if you take a value half to so much, if you take 100, so you'll find that's positive divided by positive will give you a positive. So we want this one. So the solution is obviously x here. Anyway, I'll just keep pending because this is where I have the solutions here. So I know that solutions belong here and here. But then at the end of the story, the problem is to solve the system of inequalities. So I would go for solving the other part, other component of the inequality here. So what I would do is that this one also must be taken care of. You have 6x by 4x minus 1 negative half is less than 0. Therefore, you have 12 times x minus of 4x minus 1 divided by 4x minus 1 is less than 0. Therefore, 8 times x plus 1 divided by 4x minus 1 is less than 0. Therefore, zeros are x equal to negative 1 upon 8 and x equal to 1 upon 4 here. So if you go for negative 1 upon 8 and 1 upon 4, if you take a value which is less than negative 1 upon 8, let's say negative 100 you take. Negative 100 is numerator is negative, denominator is negative. So the answer is positive, which I don't want. If I take a value between these ones, let's say I take a value 0. So if I take a value 0, 0 plus 1 is positive, 0 minus 1 is negative. So I get a negative here. So I want this one, negative. And then if you take 100 value, you find that it's positive upon positive is positive. So this is positive upon positive is equal to positive. So I don't want this one. So the solutions here, the solutions are between these ones. Now solutions here are between these ones here. Now trying to satisfy both the things. I'll just analyze the number system here. So you have a negative half placed here. Negative quarter, negative 1 by 8 is somewhere here in the increasing order. Negative 1 by 8 is to the right of negative half. And then you have a quarter here. And then you have a half here. Let's see what the first one wanted. The first one was saying that go to the left of minus half or go to the right of half. If you want solutions, go here and here. The second one says, if you want solutions, then you stay here. If you say, if you now have to satisfy both the components, that blue one says that you go to the right of half or you go to the left of minus half. The second one, green one, says that you stay between minus 1 by 8 and plus 1 by 4. If you actually try to satisfy both of them, you'd go crazy and say that, oh, I can't, I give up. So in fact, there are no solutions. So no solution to the system. So solution set is basically a null set. Satisfying the blue lines and the green lines, satisfying the value which is more than half or less than minus half, and looking for the value satisfying, keeping those conditions in mind. If you're looking for values between minus 8 and plus 4, you'll miserably fail. You say, okay, I can't find it. There's no solutions that time. So the system has no solution here. I hope you understood the lesson.